All right, let's do something easy today, shall we? Okay. Is it safe to assume that if I give you a function, you can tell me where the vertical asymptotes are?
Yes.
Or maybe we'll review that. Okay. And if that statement is true, if you can figure out where the vertical asymptote is, can you find the limit on the left-hand side or the right-hand side of that asymptote? Also debatable? All right, well, let's find out. Works better when you turn it on. There we go. Okay, so as you can clearly see, my clicker doesn't work. Ooh, infinite limits. That sounds scary. Easy peasy, lemon squeezy. Okay, nope, stop. Okay. Oh, that's right. Okay. Limits will go to infinity or to negative infinity from the left or the right. However, we're also going to talk about what are the limits at the value. That'll make more sense when we get to it. You should already be able to do this, but if you can't, I'll review a little bit so you remember, and then don't get tricked into thinking that it's infinity or negative infinity when it's just a plug and chug problem, and I'll explain that last one in a second. Okay, so let's start with that graph. What can you tell me about that graph? Something intelligent about that graph. Don't tell me that part of it's red, part of it's green, it's pretty, it's 3 over x minus 2. Tim?
That there's a vertical asymptote when x equals 2.
Why?
Because that is what it makes it undefined. Like, when x equals 2, it makes the equation undefined.
Why?
Because you're dividing by 0.
Good. So, vertical asymptotes are going to be generated wherever the function is, wherever the denominator of the function is equal to 0. If you don't have a rational function, you don't have vertical asymptotes. But you knew this already, right? But you knew this already, right?
Yeah.
Good. Okay, so let's break this down very simply. What happens as I approach 2 from the right? What's the limit? Positive infinity. Any difficulty there? Okay, what happens when I approach from the left? Negative infinity. What's the limit at 2? Does not exist, correct. What if they both point up? Does not exist, right. Okay. Now we just have some verbiage to explain that, and then we'll look at a couple weird instances, and boom, we're done. Couple new terms. Decreases without bound, increases without bound. And like it says, fancy terms for negative infinity and positive infinity. If I didn't give you the function, could you have written a pretty good approximation of that function just from the graph? Yeah. Hopefully the answer is yes. You would know you'd have an asymptote at 2. You would know it would have no multiplicity. Please tell me you know the word multiplicity. Cricket, cricket. That would be a no. Okay. We'll review that in a second. Multiplicity, well, that second is now. Multiplicity is the power on the thing in the denominator that determines the asymptote. In other words, what power is x minus 2 raised to? If it's raised to an odd power, one goes up, one goes down. If it's raised to an even power, they both go up or they both go down. Okay, here we go. Where's the asymptote? 1. Good. Any problems with that? No. It has a multiplicity of 2. So the question is, do they both go up or do they both go down? How do you know? Let's draw a picture, shall we? We shall. Good. Again, I have trouble with dashed lines, so we'll pretend that's dashed.
Well, you have a dash line.
Yeah, but it's on the other, I can't get to it right now. I can't write on top of the PowerPoint with it. Okay, so We know the function either goes both up or both down. Which one?
Both up.
Why?
Because no matter what you subtract from, or what you subtract 1 from x, it's always going to be positive because it's a square.
Outstanding. Very good. Everybody follow that? Squared value in the denominator guarantees that the function is always positive, therefore it has to always generate positive values. Okay. Now, what if we talk about the left and the right?
So suppose I want to know what is the limit as x approaches 1 from the positive of that function f of x.
Based on what he's already said, we know the answer is going to be positive. However, there is another technique that you can use, and that is put a number in just a little bit bigger than 1. So in other words, a number that we're going to hit right before we hit 1. This is calculus, so something like 2 isn't going to work, because a lot can happen between 2 and 1. We want something really close, like 1.001. If I put in 1.001, my denominator will be positive or negative. Positive, because 1.001 minus 1 is positive. Then you square it, it's going to be positive. So this is going to be positive infinity. And once we've already talked about what we have, this becomes pretty easy, and that we get that. Are we good so far? Therefore, what's this? What is it? Does not exist. We talked about that last week. Okay. Even though the left-hand limit is infinity, the right-hand limit is infinity, left-hand limit matches right-hand limit, oh, let's make it infinity. No. When you're at the point without a left-hand or a right-hand limit, it has to be does not exist. You can't give infinity or negative infinity as an answer. Make sense? Hot diggity. Let's try another one. Ashley, where's the asymptote?
1.
Beautiful. What is, let's change to, I don't know, purple. What is the limit as x approaches 1 from the positive of g of x? What is the limit as x approaches 1 from the negative of g of x? I don't know why my x turned so crazy. 1 of g of x. Ashley, what do you got for me?
Would it be negative for positive infinity, then negative infinity, and does not exist?
You said positive, negative, d, n, e. Infinity, negative infinity, d, n, e. Why? By the way, I don't know if those are right. I haven't thought about it.
Because it has a multiplicity of 1.
Okay.
So if you're drawing like this.
So one goes up, one goes down. So does it go like this, or does it go like this?
This.
Like this?
Like this. And then.
Like this is going to work really well in the video, isn't it? I'm an idiot. This in green, or this in blue. How many think it's green? Raise your hand. How many think it's blue? Raise your hand. How many didn't vote because you're a coward? There you go, at least you're honest. How do we know? You want green or blue? You're going to argue for blue. Because why again?
Because in the top there's a negative sign, so
Uh-huh.
it'll flip the original.
Are you agreeing with her? So this where are you at? Right? Is this a blue table?
Yeah.
You're like Switzerland right now, aren't you? You're just neutral. You don't really, you refuse to vote.
Yeah.
All right. But you're sitting at a predominantly blue table,
Yeah.
so you don't want to jump on the bandwagon. You are, whoa, that was easy. Okay. Lauren, what's your table, green or blue?
We're team blue.
Team blue also. Jacob, what do you got? Team blue also. Jack? Blue. Blue for him?
Except for him.
Oh, except for him. Ben, you're just fighting power right now? Okay. And actually, you were team green or green? Team?
Yeah, I was team green, but now maybe
Oh.
it's blue.
Why, peer pressure?
Kind of.
What's the rest of the group think?
I
They were turned on you like six
Support
You're all going blue, just
support
kicking Ashley off the island. Okay, in the back corner? Blue. In the front? Blue. Ooh. You're an island unto yourself. All right, somebody give me a convincing argument why it's blue other than everybody else went blue and you wouldn't want to be different because then people would point and laugh and lock you in a locker. Molly?
You plug in 2, you get negative 1.5, so if you get a negative 1.
Hold on, you're plugging in what?
2.
This is calculus.
You plug in 1.001,
That's better.
you get a negative answer.
Could you explain that a little bit more? I agree with you.
Okay. So then you'll have a negative y, which means it'll be positive x, negative y. So
Right. Everybody follow that? Yeah.
Yeah.
1.001 gives you a positive on the bottom. Negative over positive is negative. Therefore, on the right-hand side of that asymptote, it's going to go down to negative infinity. Why is the left-hand side going up? Two answers. Number one, there's multiplicity there. So because the power is odd, it has to go up if the other one goes down. Or we put in a number just to the left of 1, like 0.9999999. If I put 0.99999 in there, the bottom is negative, the top is negative, negative over negative is positive. And therefore the answer is
Because we're racing. I don't think I need to do that. I think I can just do this. There we go. Okay, so there's the graph for the first one.
there is a mistake on that slide. Where is the mistake? And by the way, I put the mistake in there purposely. What should it be? Beautiful. It's infinity from the left and from the right, but not at 1. And then the other one is right there. Where's my picture? Where's my picture? I don't have a picture. There's my picture. Okay, so it was blue. Good. Easy stuff, yes?
Yeah.
Good. I included this just so you could see some calculus speak. I know you were missing it over the 3-day weekend. All of that verbiage does nothing but explain where a vertical asymptote comes from. But you already know that. Notice the first one, however, takes a calculus definition to a vertical asymptote. If f of x approaches infinity or negative infinity as x approaches c. So it says, instead of saying, here's a vertical asymptote, now let's talk about the limits, it's doing it the other way around. Here's the limit, therefore it must be a vertical asymptote. Kind of a sneaky way of doing it. None of that matters because you can all find a vertical asymptote by looking at the denominators where they equal 0. Vertical asymptote? Whee! Oh, just kidding. Thank you, sir. How did you do? A+. I'll let you know that. Yep. Where's vertical asymptote? -1. Good. Does the 2 matter? I just discovered this earlier today. And now it's not working. Oh, there it is. I have a laser pointer. But it doesn't, it's not a, It like pulses. Could be too much caffeine.
This is for Paul.
Open your eyes a second, let me shine this laser ring.
No, no.
Thank you. Is she your backup in case things turn ugly, like somebody shines a laser in your eye? If I was to do that, would she come in and kick my butt?
Oh, yeah.
You think you can take me? You want to go? This is what I thought. Move along. I got sidetracked by the laser. Oh, yeah, don't forget you got mail. Okay. Well, don't say nice, it might be.
Still a nice amount of 10 cares.
Whether they care enough to put you in prison, or they just care enough to come and say hi and see how you're doing. Somebody still cares. Where are the asymptotes in part B? Right over there. 1 and -1, factor the bottom. Wait a second, can't you factor the top? No, I thought I could get you. The top doesn't factor. Uh-oh. Just when everything was going along dreamily, he throws a stupid trig question in there. ¿Dónde está los asymptotes de el cotangent? Spanish. Pat?
Is it every -5/2 and 5/2? Like, it's
That's-
not, because it continues, it's not just -5/2 and 5/2.
Correct, but that's tangent.
Oh, pi and 0,
0, pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, -pi, -2 pi, -3. How would you express that?
Using k, pi plus k, and 0 plus k, and
I'd give you partial credit on that, yeah. Yeah, I would probably do 0 plus pi k, or pi plus pi k. We're all done? We good? How much time do we have? Time for treats, yo! It's down in the refrigerator. You want to run down to the math office and just say, can I have the container out of Reedy's fridge?
That sounds so sketchy.
It does. And just keep screaming, don't look at it!
I'm